Look at this line of Python. Make prod called with 2 and then the result called with 3. Two sets of parentheses back to back on one expression. That should not work. Nothing we have written so far could be called twice in a row like that. It works for one reason. The first call hands back a function. Start with something simpler. Here is a function definition. A function called is even that takes one parameter, I, and returns whether that number mod 2 is equal to 0. When Python reads these two lines, it creates an object in memory, a function object, and attaches the name is even to it. That is all it does. Python does not look at the code inside. The body does not run. It runs only when the function is called, and the definition is not a call. This is not special to functions. When you write r equals 5, Python builds an integer object in memory and attaches the name r to it. When you write pi equals 3.14159, it builds a float object and attaches the name pi. A function definition does exactly the same thing. It builds an object and attaches a name. The object happens to be a lump of code instead of a number. Because a name is just a name, we can write myfunc equals is even. Read that carefully. There are no parentheses, we are not calling is even, and we are not asking whether some number is even. The name is even points at a function object in memory, and this line tells Python that we would like a second name pointing at the very same object. That is an alias, two names, one object. Nothing is copied. There is still exactly one lump of code in memory, and now two arrows point at it. Now call it. Ask is even of 4, and Python runs the code that the name is even points to, with 4 as the parameter and returns true. Ask myfunc of 4, and Python does the same thing. It runs the code that myfunc points to, the same code, and returns true. Ask myfunc of 7 and you get false. There is nothing clever happening. Python simply follows the name to the object and runs whatever it finds there. Here is the code that makes chaining possible. The definition reads def make prod, taking a single parameter, a, and inside its body sits a second function definition. Def g, taking b, returning a times b. Then at the end of make prod's body, the line return g. Look at the indentation. There is one top-level function here, make prod. The function g is nested inside it one level deeper. And notice what happens if you simply run this file. Nothing. There is a definition and no call, so no body executes at all. Think about where g lives. The definition of g sits inside make prod, so g exists only while a call to make prod exists. The main program, the outermost level of indentation, knows nothing about g. Ask the global scope what g is, and it has no answer. There is exactly one way for the outside world to learn about g, and that is for make prod to hand it back. If make prod never returns g, then g is trapped inside that inner environment, created and then thrown away, invisible forever. Now the crucial detail, the last line is return g, just a name, no parentheses, no argument. That returns the function object itself, the lump of code, not the result of running it. Compare it with return g of 3, which will call g first and hand back a number. Those are two completely different things. One gives the caller a machine, the other gives the caller a single answer. Everything that follows depends on make prod handing back the machine. Here is the program that uses it. Val is set to make prod of 2 of 3, then print val. That second pair of parentheses is the whole novelty. Python evaluates a chain of calls left to right, exactly like it evaluates an arithmetic expression. So make prod of 2 goes first, and whatever comes back is then called with 3. To see why that is legal, trace the environments Python builds. Run the program, and Python's first act is to create the global environment, the scope of the main program. What is in it? One thing. The name make prod pointing at some code. That is all Python knows. There is no call yet, so it does not care what the code says. Next line. Val is set to something, so the name val appears in the global environment, waiting for a value. To get that value, Python must make the call, and the calls go left to right, so the first one is make prod of 2. Every function call creates a new environment, so a second box appears, the scope of this call to make prod, and the global environment now sits and waits to find out what comes back. To fill that new box, Python looks at the definition. Make prod declares one formal parameter, a, and the actual parameter in the call is 2, so inside this box, a is 2. Now Python executes the body. The body says, define g. So the name g appears inside this box, pointing at some code. Python still does not read that code because g is being defined, not called. Notice exactly where g is. Inside make prod's environment, not the global one. The only way out is the next line, and the next line is return g. So make prod hands the global environment the object that g names, together with its code, return a times b. The main program now has that object. The return value of make prod of 2 is g itself. Substitute it in, and the line val is set to make prod of 2 of 3 becomes val is set to g of 3. So the line to evaluate is now val is set to g of 3. That is plainly a function call, a name, parentheses, a parameter. So Python creates another environment, a third box, for this call to g. Feel it the same way. The definition of g declares one formal parameter b and the call supplies 3. So inside this box, b is 3. Then execute g's body, return a times b. Python needs 2 values. It knows b because the caller just passed it, so b is 3. But what is a? Look inside g's own scope and there is no a there, only b. Think back to our lecture on functions. When a function cannot find a name in its own environment, it looks outward to the enclosing scope where that function was defined, not to whoever happened to call it. So where was g defined? Inside make prod. Does make prod's environment contain a name a? It does, and a is 2. Found it. Python stops there. It never needs to climb any higher. So Python uses b is 3 and a is 2. Multiplies them to get 6, and the call to g returns 6. Where does that 6 go? Back to whoever made the call. The call g of 3 was made out in the global scope, so 6 lands in the global environment, and the val becomes 6. Print val and Python print 6. That is the whole trace. 3 environments, one for the main program, one for the call to make prod, one for the call to g, and a single value traveling back through them. Why insist that a function object comes back? Change one line and watch the chain break. Suppose make prod ended with return 10 instead of return g. Then the return value of make prod of 2 is the integer 10. And after substitution, Python sees the line val is set to 10, followed by 3 in parentheses. That is meaningless. An integer is not something you can call, so Python raises a type error and the program dies. Chaining 2 calls in a row only works because the first call returns a function object. 3 ideas, 1 mechanism. First, a function definition is an object in memory with a name attached. No different from an integer or a float, and its body waits until something calls it. Second, because a name is only a name, you can attach a second one. My fun equals is even, and get an alias, not a copy. Third, a function can return another function object, and that is what makes a chain call legal. Make prod of 2 evaluates to a function, and only then can 3 be handed to it, with a still found in the enclosing scope where g was defined. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.